we are going to see about type 3. So in this, the RHS will be in the form x power r into y power s. The PI will be in the form 1 by f d d dash into x power r ys. And when we take it to the numerator, it will become inverse, that is f d d dash of inverse x power r y power s. Then when we are taking it to the numerator, if it is of the form 1 plus x the whole inverse, then we can write it as 1 minus x plus x square minus x cube, and it goes on. And if it is of the form 1 minus x the whole inverse, then we can write it as 1 plus x square plus x cube, and goes on. So here we differentiate d with respect to x and d dash with respect to y, and we can integrate 1 by d, that is when d is in the denominator, then we can integrate it with respect to x. Now we can see problems related to it. The first question is d square minus d dash minus 6d dash square into x equal to x square y plus e power 3x plus y. For this question, first we will write the auxiliary equation. Now to write AE, put d equal to m and d dash by 1. The AE is m square minus m minus 6 equal to 0. And next, find the value by factorization method. So here m is 3 and minus 2. Therefore, the CF is 5y plus 3x plus 5 2y minus 2x. In this question, we are going to find 2pi as there are two terms in question. Next, to find pi1, we can write it as 1 by d square minus d dash minus 6d dash square into x square y. Here there is no constant term, so we can take d square outside. In this step, I am going to cancel the d in the numerator and d square in the denominator, so that I can write it as 1 minus d dash by d minus 6d dash square by d square. In this step, I am going to take the common minus sign outside from d dash by d and 6d dash square by d square, so that I can write it as 1 minus d dash by d plus 6d dash square by d square. To bring in the format 1 minus x the whole inverse, I am going to take inverse for this. Now I am going to write it in the expansion of 1 minus x the whole inverse format, that is 1 plus x square, so that I can write it as 1 plus d dash by d plus 6d dash square by d square plus d dash by d plus 6d dash square by d square the whole square and x square y. Next, I am going to multiply each term with x square y. Now, as we can see d dash, we can differentiate it with respect to y. Here we can see the d dash square term, so I am going to differentiate it twice. After that, every term present in the second expression is d dash square, so that when I am differentiating it with respect to y, all the term becomes 0. Then multiply 1 by d square inside with each and every term, so that it becomes x square y by d square plus x square by d cube plus 0. As we can see that d square is present in the denominator, we have to integrate it twice with respect to x. So that first we can get x cube y by 3d plus x cube by 3d square. and then on again integration we get x power 4 y by 12 plus x power 4 by 12d. Again we can note the presence of d in the denominator, so again we have to do integration, so that I can get pi1 equal to x power 4 y by 12 plus x power 5 by 60. Now we can find pi2. So pi2 equal to 1 by d square minus d dash minus 6d dash square into e power 3x plus y. So this is of the form type 1. So here we can replace a equal to 3, that is d equal to 3, and b equal to 1, that is d dash equal to 1. After substituting we get 1 by 9 minus 3 minus 6 into e power 3x plus y, which is equal to 1 by 0 into e power 3x plus y. So when we get 0 in denominator, we will do the differentiation. So when you do differentiation, we get x by 2d minus d dash minus 0 into e power 3x plus y. And again we have to replace d by 3 and d dash by 1. So that we get x by 2 into 3 minus 1 into e power 3x plus y. And the final value of pi2 equal to x by 5 into e power 3x plus y. Finally, we have to write the complete solution equal to CF plus pi1 plus pi2.